I am here today to tell you about robots. Now, I'm sure all of you have seen some sort of robots. You've seen droids in Star Wars, right? Mm-hmm. Yeah. And you've probably seen pictures of assembly line robots putting cars together and welding them and spray painting them. And you've even probably seen at least advertisements, if not watching the show, of those battle bots, robots that go in and hammer the other robots and try and disable them. There are lots of uses for robots. My expertise has been at home building autonomous robots. And the autonomous robots are robots that have brains. They're most closely related to the welding robots or robots that can move around. You may have even seen that Amazon is starting to use them as well. They use them to roll around the warehouse, and they're smart. They have little brains on board that tell them where to drive and where to pick things up. The basis for that is having a robot brain that can run its own commands. Now, some of the smarter ones like the Amazons also can talk to other robots and talk to a main module that tells them what to do. The big difference between the battling robots and the autonomous robots is the battling robots are remote controlled. They're people that are just remotely driving machines, vehicles with weapons. Okay, that's important, that's valuable, that's, well, maybe not as important in the real world, but it's fun for its own style. But it's not smart. Yes, it may have little computers on board that help a little bit, but the real brains behind it are sitting behind a remote control on the other side of the safety screen. I think it's more interesting to figure out how to tell a robot what to do before you ever turn it on. You tell it what to do, and then it runs commands and figures out what's going on in the real world. Robots, as a hobby, I look at as having three different parts. You have digital electronics. You have to run wires between different parts, and that sends different digital voltages. You have to run programs, write programs that can go through the code and look for those signals and react to the different signals that happen on these robots. But there's also the mechanical part. You have to be able to build the pieces that work in the real world. And that can be really challenging because you have to do it on a small platform that doesn't interfere with the robot brain, but works well with it. And the robot brain has to be able to talk, not just digital, but sometimes analog. It has to be able to send different voltages or different amounts of power to wheels. It has to be able to look for things around through ultrasonic sensors or light sensors or related other sensors. To be able to do all this, you have to be able to do those things in different phases. And if one of the things is not working well, the whole thing may not work well. And being able to figure out where is the problem can be a big challenge. For me, when I first got involved in hobby robotics, I looked at all sorts of different little brains that were available. I looked at different kits that were available. But when I first started, there weren't many kits at all. And I wanted to figure out, is it possible to build a robot at home for under $50? And the answer is, if you're willing to use parts that you find around the house, you absolutely can build a robot for under $50. I've used tuna cans as the wheels. It's the mainframe, which allowed me to pack the motors inside. These are, inside the motors are servos from remote control airplanes made to be able to run in a circle. I used paper clips as the framework that holds everything together. I created a little bit of plastic bottle that is the insulator for the circuit board. And the circuit board was a kit from another robot hobbyist that he sold the kit for $13. Therefore, the whole kit cost me under $48 with the extra sensors I've added. Now this has sensors on top that allow it to look around for when it's approaching a wall. I've added sensors on the bottom that let it look for the edge of a table or to follow a line. Now the interesting thing is it's got this tiny little brain here that is programmed in a language called BASIC. There are lots of different languages available for robots, and there's lots of different things you can solve with robots. But robots are about interfacing to the real world using small electronics. And that small electronics is a special CPU called a microcontroller. A microcontroller is different than the standard CPU inside your computer. The standard CPU inside your computer needs lots of other chips to be able to talk just to your keyboard and just to your video monitor and to be able to make sound and to be able to talk to the internet. Each of those has separate parts inside your computer, separate chips, separate sub-chips, separate systems, separate plug-in boards that do all these different parts for you. But on these small computers that run robots, you have a microcontroller. It's a single chip that has memory, that has ROM, that is memory that doesn't go away. It has the ability to talk to analog devices, run motors, turn on lights, turn on switches, look at sensors. So each of these things are important for being able to program in a microcontroller. There are extra instructions and extra ways and extra memory locations that you use inside of a microcontroller to be able to make your robot work. Anybody can be building different parts of robots. You can start as simple as buying a Lego robot kit. They're expensive, but they're very fun to start with, and they give you a language that can be a lot simpler to get started with. But if you're really interested in making a robot that works smart, works well, and challenges you, you need to figure out how to get a microcontroller, get a kit that lets you put it together and interface it to the real world. Building a robot doesn't have to have tuna cans, but it can be something that you can do at home. But it's even better if you can share it with others. I was lucky enough to have a group at the time that I shared with. Working with others allows you to lean on each other's strengths, find out what's not working well and find out what is working well. And you get to learn so much because it's multiple discipline. It's not just electronics. It's not just hardware. It's not just writing programs. It's all together a multiple discipline intelligence that you get to learn all about. You too can do robotics at home, and you can find out more through maker fairs and through other activities.